Good day. Welcome back for our next lesson on grade 11 probability. Within this lesson, we're going to discuss the two-way contingency tables, or in short, we just call it two-way tables. This is a part of grade 11 probability that is not really very difficult, a very popular question in the exam as well, and very easy to understand. So let's have a look and see how it works. In this example, you can see the table first of all, and the reason why they call it a two-way table is for the fact that you can read this table horizontally, then it's about the gender, male, female, or you can read it vertically, which is about pass and fail. So that's where the name comes from a two-way table. Now, this is about 150 grade 11 learners. Now, again, always important that 150 will be your sample space. But you will also see it's right here, the big total, 150. That is your sample space. And this shows the mathematics results of the males and females in terms of pass and fail for a test or exam. Now, the males that pass is 63, fail is 7, that is the total number of males. Females, 72 pass, 8 fail, that is the total number of females. And if you look vertically, the total number that failed is 15, the total number that passed is 135. So let's look at the first question. Questions say that if a learner is randomly selected from this group, what is the probability? So again, we are looking at the probability. So that means we must divide with the sample space. So just remember the N of S in this case is 150. That is our sample space. Now the first one, they ask us, what is the probability that the learner is male? Now, to find this probability of male, and you're welcome to even write it down in words, is then how many males divided by the sample space of 150. So to know the number of males, we look at the males and we look at the total, which is 70. So that means it will be 70 over 150. And if we simplify, you get 7 over 15. And that is the probability that if a learner is selected, that learner will be male. So we not take pass and fail in consideration because it's only about male or female, in this case, about the males. In the second question, it's about pass. What is the probability that the learner passes? And now we need to look vertically at pass. And that is the total number that pass, and that is the sample space. So what we will do here is we will say the probability of pass is equal to 135 over 150. And we can simplify that, and you will hopefully agree with me, you will get 9 over 10. I just want to write it down again, which gives you 9 over 10. And that is the probability of pass. So as you can see, when they ask you for one event to happen, then quite easy. If it's about the gender, then we look at this, at those totals. If it's about pass or fail, it's about these totals. But what we after is exactly the next question. That is where they ask you, what is the probability that a learner is male and passes? So now you have two events here. So horizontally, we're going to look at male. Vertically, we're going to look at pass. And I think you agree with me, that will be that 63. So the number of males that pass is 63. And that is then divided by the sample space. So we can write this as the probability of this event is then the, like I showed you, is how many males pass, because it's about male and pass, and that is the 63. And I would say 63 over 150. And that, of course, we can still simplify also to 21 over 50. Divide numerator and denominator by 3. The fourth question here is very exciting, and you must read carefully. This one was an and, this one is an or. So this question is not very common, but quite interesting to think about it, because this or, you will remember from the rules that we did or, we can't really easily read it from this two-way table. But you will remember what we said about whenever they ask us to find or, and that is to use the general rule. And that is what I will suggest we use here. So I'm going to say the probability of female or pass, and I'm going to use pass for the simple reason, if I use P, then it's confusing because it's probability then of P. It's equal to the probability of female plus the probability of pass minus the probability of female and pass. So you remember from our previous sessions. So now to find this or, we're just going to substitute. Because to find probability of female is not difficult, because we do it the same way as what we did with males. Probability of male, total number of males. Now probability of female, total number of females is the 80 over the 150. Plus the probability of pass, and that is the one that we did earlier. Probability of pass, you will remember we did it in number 2. So we have the answer. I'm going to keep the answer for the time being. I'm going to use 135 over 150 so that I have a common denominator here, and then it's much easier to calculate. But of course, you are allowed to use a calculator. Subtract the and. Now, this and is about female and pass. The one we did earlier was male and passes. So now it's about female and pass so we're going to look at female and pass, and that is the 72 over the 150. And that gives us the 72 over the 150. So now you can see we've got a common denominator of 150. And if we add that, subtract the 72, I hope you are happy when I say that your answer for that, if I quickly calculate, is 143 over 150. Because all I did was I took the 80 minus 72 is 8, and then the 135. So it's this 80 minus the 72, and that leaves you with 8 plus the 135, which gives you the 143 over 150. And that is the probability of female or passes. So that is the kind of questions that you can expect within a two-way table whenever you get questions like that. The last part of this example, this one say, determine whether or not being male and pass if they are independent. Whether or not. So they are not saying it will happen. So what this means is, in general terms, does gender influence mathematics results? And our sort of common sense tells us no. So we tend to think they will be independent, but of course we need to show them. So now we're going to do exactly what we discussed in our lesson on independent events. We're going to check the rule. So we're going to start off by saying the probability of male and pass. I'm just going to use pass. And that one we calculated already, the male and pass. You will remember that we did here in number 3, male and pass. So now we look at being male and passing. So now we can just write down that answer, which we set in number 3 was 21/50. Now, to compare them finally, the two sides now, this is the left-hand side, we always preferably take this to a decimal number and we round off to 2 decimals. And if you take this to a decimal, not too difficult to do, 0.42. So that is the left-hand side. So now for the right-hand side, where we look at the probability of male times the probability of pass. So these are now 2 separate ones. But the probability of male, you will remember, that we already did as well. It is this one, the probability of male. And that was the 17/15. So I'm just going to use that, the 7/15, multiply by the probability of pass. And now if I just want to point out, where do we get that probability of pass? And you hopefully agree that's what we did in number 2, the probability of pass. And that was 9/10. So we're going to multiply by 9/10. Now, you can do this easily on your calculator and write your answer to 2 decimals, 0.42. And what do you notice now? Can you see your left-hand side 0.42, your right-hand side 0.42? So this means that the probability of male and pass is equal to the product. So we can now say the events are independent, like we expected. So sometimes it's possible to sort of predict up front if they will be independent or not. But always in exams, your examiners would like to see this. So you need to show them what you did, how you got to it. So this is our first example. So let's look at the next one. All right. In this one, it's about a sample of 100 men and 200 women are tested for color blindness. So this is what this table is about. So you will see vertically it's about the gender, male, female. Horizontally, it's about colorblind or not colorblind. Now, you can see there are unknowns in this table, 5 of them. And they ask us, first of all, to write those, the values of A, B, C, D, and E down. Now, that is very straightforward. So I'm sure no one of you will have a problem. Because remember, if I look horizontally, this 2 must add up to 10. So you agree with me, A will be 9. So A will be equal to 9. So now we will look at the next one. And the order is not really important, in what order you do it. So this one is 9. I'm just going to put it on the table. So you can see 9 plus 1 is 10. Now, if I add them vertically, 9 plus what is 100? Or you can say 100 minus 9. And I think you agree with me that will be 91. So we can say B is equal to 91. Then if we look at those ones, at these ones vertically, then you see 1 plus whatever is 200, or 200 minus 1. And that, of course, will give you C, and that C clearly 199. So C is equal to 199. So now A, B, and C we have. So now we can now find D, and D is the total if I add them horizontally. So that 199 plus the one is 200 plus 90. So I think you agree with me, that will be 290. So D is equal to 290. Now, to find E is quite easy, because you just find the total of those two or the total of these two. But that was also given to us, 100 men, 200 women. So our sample space is 300. So that means the N of S is equal to 300, and that will be 300. So that means C is equal to 300. So that was a very easy question. They sometimes ask the question like this. Be very happy, because it's quite easy to answer those, to answer that. So let's look at the B part now. This is similar to what we discussed in the previous one. They ask us for the probability. So that means we're going to divide by the sample space. That if a person is chosen randomly from this sample of 300 people, what is the probability that person will be female? So we want to know how many females. So it's the probability of female. Our sample space is 300, so I write it down immediately. And what is the number of females? So when we look at females, the total number of females, 200. So we will get 200 over 300, and that, of course, is 2 over 3. So that is the probability that if someone is chosen randomly, that person is female. The next question is colorblind. So if I want the probability of, and I'm just going to use CB for colorblind, then my denominator is 300, and I just need to find the numerator. So I need to know how many people are colorblind. So I follow colorblind, and you can see that is 10. So I will say 10 over 300, which is 1 over 30. And I think you all agree with that. The third one, they ask us, what is the probability that if a person is chosen randomly, that person is female and colorblind? So we must now follow female and colorblind. Colorblind, female, there's only one. So colorblind, female, 1 over the sample space. So the probability of this event is then 1 over 300. And I'm pretty sure you are quite comfortable with what we did up to here. Now for the last question, number C. And this is very popular whenever they test two-way contingency tables, that they will ask you about independent. Now, just to point out, they say, is color blindness independent of gender? So they didn't specify which one you must use. Must you use female or must you use male? And it doesn't really matter. You can use any one of the two. My suggestion will be, because we already worked out the probability of the and, you can see here, of female and colorblind, that I'm going to use those two events to answer this question, because then because I've got that question already. So I just need to put that in so that we have it. That is 300. So I'm going to go for left-hand side. It's equal to the probability of female. I'm going to use F for female, and colorblind, and I'm going to use CB, just in short for colorblind. Now, as you can see, that we did already, the and between female and colorblind, and that was 1 over 300. And that, of course, we can take easily to a decimal, which is 0,003. So now I'm going to go to the right-hand side, and that is the probability of female times by the probability of colorblind. Now, if you remember correctly, that was exactly the questions in number B. Probability of female, we did it. Probability of colorblind, we've got that one as well. So you don't need to work it out again. So you can see why I selected colorblindness with females, but it doesn't really matter if you wanted to use male. So let's just write down probability of female. As you can see, we wrote it down, and that was 2 over 3, multiplied by the probability of colorblind, and that was 1 over 30. You multiply that, you put it to 2 decimals, and your answer then 0,02. And as you can see, left-hand side is clearly not equal to the right-hand side. So what does that mean? These events are not independent. So when this rule for independent events are not, doesn't work out correct, and please remember, you must do it separately, left-hand side, right-hand side. And if your answers are not the same, they are not independent. Like in the previous example, if the answers are the same, they are independent. Thank you.